Okay. So next example within the stored procedures, we have seen looping through the table by using cursor statement, right? So I want to show you about loop. We can also loop through the table. You remember we have seen syntax in the select statement of what in limit and offset, like where we can say limit so many records and offset eliminate so many records. By using that also we can basically loop through this. Okay? So if you see the code, again I'm just declaring these variables. So I'm going to consider this table my table 1 and going to read the record by record from this. So what I'm doing, I'm just saying first I tab equal to select star from this table. So I'm just collecting all the data from this table into this temporary table called I tab. Then at the same time, I'm just collecting this count of this records into this variable LV main count. Okay. And what I'm doing is only the data is there in the table. It's very important. We do not have size subbar C. So instead of hitting the table when it is blank, what I'm doing, if the main count is not equal to 0, if the table contains records, then I'm saying select count into LV count from the I tab. I'm just counting the entries from this I tab. Then if LV count is greater than 0, then I'm saying loop and end loop. Now within this loop, I'm saying if the LV count is initialized with 0, sorry, LV count is initialized with the count of records in the I tab. Let's say there is 8, and the loop count will be 0, and 8 is, whenever this does not satisfy, I'm breaking out. If it is really satisfying, then what I'll do, I'm just reading this employee ID name into this variable from this. I'm reading from I tab, not from the table. Then I'll say limit 1 and offset and keep on changing it. So now initially your offset will be, loop count will be 0. Then when you say limit 1 offset 0, offset means it does not take out any record. So first record is read. In the second loop, loop count will be 1. So it's when you say limit 1 offset 1, first record is eliminated and then reads the first one record. Same it goes through that loop and keep printing it. I'm just running the loop. Yeah. Okay. Now it's better. So what I'll do, I'll just activate this procedure. Then I can use this call function to call the procedure. Procedure will just print me all those records. There are 8 records. So each loop it just prints in 3, 4, 5, 6, 7, and 8 records. And we can also debug this and look at this. 9 cubics procedures. Refresh this one. So you'll have temporary table. So I just want the breakpoints and numbers. Then I would get into debug mode. In the debug configurations, I'll choose. So now it starts here. So there is no iTab yet declared. Since I'm using this temporary table within the code, it does not need any explicit declarations. When it says iTab equal to select, the result of this select statement will be collected into this iTab here. Yeah. Now let's say execute this line. So I see no iTab here. On fly that gets declared. Now you see this iTab with how many rows? 8 rows. If you want, you can see that. Select this table, right click and say open data preview. So here at the bottom, you can see the content of this iTab. Temporary table has got 8 records now. Okay. Okay. Now we're going to read the count. What is this LV main count? Is initially 0 now. Let's execute this line. You're going to get count of records as 8. So now 8 is not equal to 0, so it gets into the next line and then reads the number of records in the iTab into this LV count. So again, the iTab still has got 8 records. Then I'm going to loop through this statement. And my LV count is 8 and loop count is 0. So is 8 less than this? No, right? So it does not break. So it gets into next part where it says select employee ID, employee name from into this local variables. You can use this local variables like work area. We don't have like. Then you can use this from iTab. From temporary table, I'm reading these 2 columns and placing that into local variables. But when I'm reading, I'm saying loop count is 0 now. So limit 1 record where the offset is 0. So when it reads this, you get the first record into these variables. See, LV employed has got 1 and name has got Pratap, which is first record of the table. And then when you say select so and so from dummy, it actually prints this record. Okay. Done. Again, I'm incrementing this loop count by so LV loop count equal loop count plus 1 will make the loop count as 1 now. So then when the loop again gets in, now this time the loop count is 1, so it says reads limit 1, offset 1. So when you say offset 1, it is going to read the second record into this. So second record is employee ID 2 and Sri. Like this, it keeps reading the third record again. Now loop count is 2 now. So it is going to eliminate 2 records and limit 1. So it is going to read 1 record, which will be by eliminating 2 records at the top. So where it reads. Okay. Then you'll be looping through this. Now LV loop count is 3, so it basically loop count is 2. It eliminates the first 2 records and reads 1 record, which will be third record. Like this, it keeps reading it. So if you want to cut down this, you can say terminate. So then debugging stops, then I can get back. So like this, there's another way of looping through all the records in the table, either by using cursor or by using this temp table concept where you collect the data into temporary table and loop through each and every record of a record by using this limit and offset, where you keep making your offset dynamically changing as 1, 2, 3, so it keeps reading the next record. Yeah.
Hello.
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 Yeah.
Sir, whatever ITAB results is there, we are printing those ITAB results in the output, right? That is the purpose of the loop, right?
No, see, my intention is just to loop through. So demonstrate that I'm just printing. Yeah.
So in ABAP, we have for all entry concept is there, right? That is not applicable in this case because in ITAB, yeah,
What concept? What concept?
for all entries. In
No.
ITAB, we have 9 entries.
HANA will
Yeah.
not have for all entries. No. HANA will not have for all entries. No. So even when we were working with BW on HANA, we are not supposed to use for all entries, because when you use for all entries,
Okay.
there is a program called ZBW underscore ABAP underscore analyzer, where
Okay.
SAP is giving this, that is a node. When you use that node and run through this program, that will tell you that this particular statement for all entries is not a valid statement. It is valid, but
Okay.
for it, you're not supposed to. It's not red. It is yellow. Yeah. Yeah.
Okay.
Yeah. Next one, try catch block. ఎవరు ఆయన ఎన్నిసార్లు చెప్పినా ఆయనకు అర్థం కాదు, ఏమి పరిస్థితి అయింది. Okay, boss. The next one. Boss, who are you, boss? I'm not understanding. Why are you disturbing the class like this? So next thing is about try catch block. బస్ ఎవరు బస్ నువ్వు, నాకు అర్థం కాలే. బస్ నువ్వు క్లాస్ ఎందుకు డిస్టర్బ్ చేస్తున్నావు అన్నా? నువ్వు ఎవరు, నీకు అంతగా అవసరమైతే నాకు ఫోన్ చేసి మాట్లాడు, ఫ్రీగా అటెండ్గా. ఏంది చదవడతా? Okay, but next is your try catch block. So when you're implementing short procedures, we'll always have a requirement. Say for example, you're running through the procedure, and let's say you would like to raise some exception. Say, let's say you're reading some table and then there's no records in the table and you would like to raise some exceptions. Then we can use this try catch block. Yeah. Now here we have it. Yeah. Now this is how you handle this try catch block. Say for example, now what I want to do is I just want to read some records from a table. Say select count of star into this variable from this table, some table. But actually you raise an exception when it is not, when it is zero. But for me, for now, to raise, I'm just saying if there is data in it. So if count var is not equal to zero, then I'm raising the signal. If you say you use resignal signal here, you say signal customer condition and set this message here. And at the top, we would have declared this condition saying customer condition, and the condition is for this SQL error code. Okay. Now, when you say signal here, it basically sends a signal to this here, the declaration part. We have declared the exit handler here. When you raise a signal, it gets into the exit handler, which is for custom condition, saying that it just has to print that error code and the error message from dummy bus. So whenever this is not satisfied, I'm raising a signal, okay, and it raises signal out and gets the custom condition and passes this message here. And as part of this handling of this signal, I'm just collecting that message as error message, and the error code I'm just printing that, nothing else here. Okay. If I just go with this, I think this table may not be there. I'll do some table. ఎవరు నువ్వు అసలు నాకు అర్థమే కాదు ఎవరు నీకు ఎన్నిసార్లు చెప్తే అర్థం కాదు బస్ మీరే వాళ్ళకి లింక్ ఇస్తాండేది ఇష్టం జస్ట్ ఏ కాల్ so I'm not just passing anything, I'm just call this. It just prints me a message this with this error code, and we can pass in some message here. So like this, we can basically use a try catch block where you basically check some condition, you raise a signaling, and it basically and we handle that signal by using exit handler here, and then do the operation what you want to do when the signal is been raised. Yeah. Next one, very important.
Sir, can I have a question? Hello?
Yeah, tell me. Yeah, hello. Yeah.
Yeah, this signal error is same as an
Hello.
other databases have. Hello?
Hello. Yeah.
Sir, can you hear me, sir?
Yeah, now better. Yeah.
Yeah, this signal error is the other databases has the same one, is it? It is same signal error that we use in other databases.
Yeah, it's same. Yeah, exactly.
So for example, if the table doesn't has any data, you try to throw an error saying that there is no data found in the table.
Exactly. Same. That is the same. Yeah.
But in real scenario, do we exactly use this kind of?
Yeah. We have to use in real time scenario. We have to use this a lot because when you try reading data from a table which has got zero records, it throws an error actually. And in ABAP, we have a concept called size subversive which can control this. Since you don't have this, you have to explicitly So when you're writing a scripting, it becomes a process that first, before you read any table, you get the count of those records from the table. Okay.
Okay.
Then check if the count is matching. If the count is greater than not equal to zero, then equal to zero, then you will raise a signal. And if it is not equal to zero, you will allow the program to start reading further. Yeah. That is where you.
Yeah, here exit handler importance is that it, I mean, whenever there is no data in the table, it just exits the table, is it?
Exactly.
That is what this exit handler does.
Yeah. Yeah. So generally when you do
Thank you.
control that, it goes for a dump. So unnecessarily procedure gets into failure mode, saying cannot read data from some table like that. Yeah. Instead of getting those kind of
Okay.
issues, it's better you go on with this. Yeah. Fine.
Okay. Thank you.
Sir, one question, sir.
Yeah.
Hello.
Yeah. Please. Yeah.
Yeah. Is that mean that we are running a application in between? We should not come out complete process of that application till execution of end of the line. Is that correct?
No, see, actually, when you write some procedure or any program, you intend that to be worked out completely. But in any case, when something doesn't get satisfied in between, you want it to raise an exception. That's where you control it, use the signal concept. That's it. Yeah.
Yeah. If you don't use that error handling here in between that,
Yeah.
so it will
It'll go
completely
for
come out from the
yeah,
application,
it'll go for
right?
abrupt error. You will not understand that error also. Yeah.
Yeah, in between it will come out from the complete application without execution. If you get any error or
Even now
no
it
data records
even
found.
now it comes out, but at least you'll be in a position to understand the error message where it has failed. Yeah.
Oh, okay, okay.
Yeah.
Right. Thank you.
Sir, on line 17, should it be equal to 0 or not equal to 0?
Yeah, it is supposed to be equal to 0. Since my table has got records, I wanted to just show the signaling. I put not equal to 0. Yeah.
Oh, okay, nice. Thank you, sir.
Generally, when you want to really check for the records not there, you put it as equal to. Yeah. But only intentionally for me, I don't have a table with no records here, so I'm just putting the table as not equal to, just to show you signaling there.
Okay, sir, thank you.
Next one, CE functions, very important to us. Yeah. Okay. Very important CE functions. Yeah. So we call this CE functions or calculation engine functions. So what SAP has done is, for most frequently written select statements, SAP has given some ready-made functions called CE functions. SAP has given some ready-made functions called CE functions, calculation engine functions, which basically can be used by replacing the most frequently used select statements. For example, so you write it normal procedure, write it as like select star from this table, right? Instead of writing select star from this table, you will have some ready-made CE function which can do that operation for you. Say you say select some column 1, column 2, column 3 from some table, where so and so. To do this, you will have some corresponding CE function given. So we are trying to understand what are the different CE functions available and what is the purpose of each of this function. Okay. You understood this, right? So basically when you use CE functions, you get more performance because it is going to leverage calculation engine. If you write normal SQL, it does use SQL engine. When you use the CE functions, calculation engine functions, it does leverages calculation engine, which is huge, which is really fast. So what SAP has done is, instead of you writing a normal select and getting it executed with the SQL engine, what SAP has done is they've given some more the functions called CE functions, which can be used to replace your select statements there. Okay. Now let's see what all do we have. Very, very important. First one, CE underscore column underscore table. This is the first function, or CE operator or CE function, anything is fine. So we use this function CE underscore column underscore table when you want to read data from a column store table. Let's say when you want to read data from column store table, what do you say? You say like select star from this table, or select column 1, column 2, column 3 from table, right? Those particular select statements can be replaced by using this C operator called C underscore column underscore table. Yeah, if you don't understand, please stop me. This topic is very important. Yeah? So C underscore column underscore table is a C operator which will be used when you want to read data from a table. It could be all the columns of the table we can read. If you want, you can read only some columns of a table, certain columns of a table also. Either ways, you can use this function operator. Yeah. Next one, CE underscore join underscore view. Yeah. That's the next operator. Okay. Now, what is the importance of this? Okay. Now, before we get into these other three, let me just give you some information so it is easy to recognize. So, as part of HANA modeling, we are going to deal with three views. One is attribute view, analytical view, and calculation view. Yeah, fine. As part of HANA modeling, we are going to deal with three different type of HANA modeling views. One is attribute view, analytical view, and calculation view. Okay. So, and next point is, when you basically execute a query on attribute view, internally it leverages join engine. Yeah. When execute a query on OLAP analytical view, it uses OLAP engine. When execute a query on calculation view, it does leverages calculation engine in the backend. So you'll have three different modeling objects, modeling views: attribute view, analytical view, and calculation view. So for attribute view, to process the data through attribute view, it does leverage something called join engine internally. To process data through analytical view, it does use OLAP engine. To process data through calculation view, it does leverages calculation engine. So this is how we'll have three views with three engines in the backend. Okay. And next point, I don't know how many of you remember this. I told you about column views and modeling objects. Say whenever I create either attribute view or analytical view or calculation view, it does create some runtime objects which are nothing but your column views in SysBig schema. You understand? I don't know if you remember this or not. I told you. For example, other day for demo, we just created one view, right? Every time you deploy a view, whether it is attribute view or analytical view or calculation view, so this view name is what? Sales reporting underscore 9 cubics. It automatically creates this runtime objects in a schema called SysBig. I don't know how many of you remember this. In SysBig, we had a column view created, but if you remember, this is 6 cubics, right? 6 cubics, and if you go to see, you have this in the 9 cubics package. We have sales reporting. So is this a column view bus? I created a calculation view and deployed it, nothing but activated it. When I activate it, it automatically creates the runtime objects, runtime column views in the sysbig schema. Okay. Say this is not only for calculation view, either attribute view, anything. So whenever you deploy an attribute view, or whenever you activate an attribute view, or whenever redeploy, another reactivating it, attribute view or analytical view or calculation view, it automatically creates this column views, which are considered as runtime objects in sysbig schema bus. Okay. So now you know the views, you know the engines, what it does use. Now look at this name. It says CE underscore join underscore view. Okay. So basically we use this function when you want to read data from a column view which is generated from the activation of attribute view. See join, we see this word as join. Now consider this join engine. Join engine is used to read data from which view, which HANA modeling object, attribute view, right? So now understand this easily. So when you activate an attribute view, it creates a runtime column view in which schema, sysbig schema. So when you want to read data from that column view, which was generated from the activation of attribute view, then I use this operator C underscore join underscore view bus. Okay. Next one, we have C underscore OLAP underscore view. See, the name tells you what is OLAP here. OLAP. So OLAP is an engine which is used to read data from which view bus? Analytical view. So we use this view operator C underscore OLAP underscore view when you want to read data from a column view which was generated from the activation of the analytical view bus. So when the analytical view has been activated, it automatically again creates a runtime object which is a column view in sysbig schema. So when you want to read data from the column view which was generated from the activation of analytical view, which is for OLAP engine, so then we use C underscore OLAP underscore view bus. Okay. Next, C underscore calc underscore view. Calc is calculation engine. So calculation engine is used for calculation view. So same now. When you want to we use this operator or function C underscore calc underscore view when you want to read data from the column view or the runtime object of sysbig schema which was generated from the activation of calculation view bus. Let's say you have activated calculation view, it creates a runtime object column views in sysbig schema and you want to read data from that column view, then we use a function called or operator called C underscore calc underscore view. Okay. So from either of this, either when you use C underscore column table or join view, OLAP view, cal view, you can read all the columns or you can list out the columns what you want also. Yeah. Next one, CE underscore join bus. CE underscore join. See, that is in the interviews they ask you this question generally. What is the difference between CE join view and C underscore join internet? Generally in the interviews they have this question. First they'll ask you what is C underscore join underscore view. Then you start answering it is for joining. You will forget about, by looking at the keyword join, you say it is for joining. Then they'll ask you then what is the importance of CE join bus. So the confusion is CE underscore join underscore view is for reading data from column view which was deployed from the activation of attribute view. Yeah. But when it comes to C underscore join, we use this operator when you want to join two tables. When I say two tables, it is not two database tables, two temporary tables. C underscore join is an operation through which you can perform an inner join between the content of two temporary tables, not database tables. For example, I have database table department. Let's say I have got database table employee and I would like to perform an inner join between these. So I can't straight away use C underscore join. First what I should do, I have three operations here. First I should read data from employee table. First I should read, secondly I should read data from the department table and then join those results. So what I'll do, first I'll use a function called C underscore column underscore table to read data from this department table into one temporary table, let's say I tab 1. Then I'll use C underscore column underscore table to read from employee table and collect that into I tab 2. Then I'll say C underscore join the content of I tab 1 and I tab 2 and with this one column. Getting this? So C underscore join will be used when you want to perform an inner join, but this can perform inner join only on temporary tables, not the database tables. So first you will have to read data from this database tables by using C underscore column underscore table if it is a column store tables. Then once the data is collected into temporary tables, you have to go about joining both of them by using C underscore join bus. Okay. Next one. Let's say now C, this is straightforward. C underscore left underscore outer underscore join, that is again straight away for left outer join. So again, this again does not join two database tables. This again joins two temporary tables. So if I have the requirement of performing left outer join on two database tables, what should I do? I should first, by using this C underscore column underscore table, I'll have to read the data from table 1 into temporary table. Then again read the data from table 2 again by using C underscore column underscore table to temporary table 2. Then perform a left outer join between these two temporary tables, tab 1 or tab 2, by using C underscore left underscore outer underscore join. Yeah. Same way, if you want to perform a right outer join between these two tables, use C underscore right underscore outer underscore join is a function when you want to join the two tables. Again here we can only perform join on temporary tables, not on the database tables. So the logic of joining would be what? First collect the results into temporary, first collect the table content into temporary tables, then go about using these temporary tables to perform a join or left outer join or right outer join. Okay. And not to get confused with C join and C join view. C join view is used to read data from the column view which was generated from the activation of attribute view. And C underscore join will be used when you want to perform an inner join. Good. Next, we have other operator called C underscore projection bus. See, let's say I have a select statement like this. Two things you can do with projection. One is projecting only certain columns and applying a where clause bus. And applying where clause here. Okay. Say for example, I have a select statement like this. I have a table with 5 columns. I want to read data from this table, so I use C underscore column underscore table for it. So I'll say C underscore, by using C underscore column table, let's say I've read all the columns of the table into temporary table 1 I tab, but I don't want to project all those 5 columns. Then again I can say I can use a C projection on that I tab and just project only column 1 column 2. That is one option. Other option is while reading data from database table itself, we can just read only 2. So by using C underscore column underscore table, I can just read only column 1 and column 2. I have that. But let's say for some requirement, you've read all the 5 columns from this database table by using the C underscore column table into I tab. Now, but from the I tab, I would like to project only 2 columns, not all the columns. Then I can say C projection of I tab, project only column 1 comma column 2. So I can do that. Okay, that is what we can do with C projection. Yeah. And when you want to implement where clause in a select statement, that is not possible in C underscore column table, because C underscore column table can only read, no where clause. And if you want to apply where clause, it has to be done on the C projection only. So C projection is for projecting certain columns of a table and also for applying a where clause. Okay. Next, C underscore union underscore all. C underscore union underscore all is another operator. It's like union. Say again, this also plays only on temporary table result set. First collect the data from table 1 into tab 1, I tab 1, and table 2 to I tab 2, then perform union bus. So when you say union all, it basically includes even the duplicates also. Union all, it also includes the duplicates also. Yeah. Okay. And next we have another C operator called C conversion, which can be used for performing currency conversion. So in a we'll see this. I'll show you this. In normal SQL also you have a function called currency conversion through which you can do currency conversion. Apart from this, we can also use the C conversion, C operator to perform the currency conversion. So we just have to pass in all the parameters, source currency, target currency, exchange rate, all this. Then it does do the currency conversion. Yeah. Then C aggregation. So when you want to
Sir,
perform, yeah,
sir, is it only for currency conversion or UV conversion too?
currency conversion, currency conversion.
Okay, sir. Thanks.
And then C underscore aggregation is for aggregating the records. So when you say aggregating the records, let's say you want to say sum of, in the normal select statements, do you write something like say select sum of, max of, min of, and then whenever I use these aggregate functions, I must go with using group by clause, right? Same way, when you want to implement that aggregation functions with the group by clause, we go with aggregation. Say I have lot of records of same records of south, and I would like to aggregate this record with some aggregation function, then I can go with C underscore aggregation bus. Then I can use what? C underscore aggregation. So C underscore aggregation will be used when you want to aggregate your records, so by using some group by function and some aggregation function like sum, min, max, all count, all this. Yeah. Yeah. Then we have another function called C underscore calc. Let's say within the select statement you can perform some calculations, right? Let's say I have price and quantity as two columns. I would like to multiply both these and result as amount. What you say is it says select price comma quantity comma then you will say price into quantity as amount, right? So when you want to implement those kind of simple calculations, I can use a function C underscore calc to perform those calculations. And one important point before we see the demo on these functions, what SAP suggests is, see now I can, so now for most of the frequently written select statements, I have the SQL CE functions, right? So instead of me implementing the stored procedure with select statements, normal SQL, we can also implement my logics with CE functions, right? So I can implement my stored procedure with CE functions also. Yes. So first preference will be to implement with CE functions. If there is some logic you're not able to achieve with CE functions, then you'll go with normal select statements only, normal SQL. Yeah. But SAP says do not mix up both. Say for example, you're writing a stored procedure. Do not write some lines with CE functions and do not write some lines of code with normal SQL. No. Either write the code completely with SQL, okay, or write with using SQL functions. Okay, boss. Now let's.
Sir, I have one question.
Yeah, please. Yeah.
Yeah, you are saying that this joins and call views, we have to use a temporary table, then only we can apply all these CE functions on remaining
Yes.
the operators.
Yeah,
Yeah,
for CE,
overlap
fine,
view.
I did not tell that point. You C
Yeah,
understood
the other ones.
the other ones. Yes, yeah.
Yeah, so we have to use temporary table. In that case, we have to write a procedure and then we have to use the CE function in that procedure, right?
Exactly.
Because we cannot
That's what
create a temporary table directly.
exactly. That's what, as part of stored procedures only, I'm touching this concept as CE functions. When you write stored procedures, instead of using normal SQL statements, we can in turn use CE functions also.
Okay, but you said just now that we should not mix up both SQL side
Yeah,
and this.
yeah. Don't mix up. Either implement your complete logic with CE functions, or either implement complete logic with normal SQL.
Uh, but here is the question that if we don't use, if we don't mix up both of them, then how can we achieve this temp table concept?
Why? We'll see some examples now using this, then you'll get some idea on how I'm working it out. Yeah.
Okay, fine. Yeah.
Yeah. I'll be showing some.
One doubt here.
Yeah, please. Yeah.
Yeah. In earlier statement, you have written one SQL statement, right? The SQL statement, something set SQL statement, something like this, which reads only the SQL data.
Sorry, I
I
didn't.
don't remember exactly. I mean, మీరు SQL statement and only SQL script read చేసి ఒక statement setup చేశారు కదా earlier statement లో.
Earlier example.
Read అంటే ఇప్పుడు కదా ఇంతకు ముందు
ఒక స్టేట్మెంట్ లో
సెట్ SQL డేటా సంథింగ్ ఆ స్క్రిప్ట్ యూజ్ చేశారు కదా
సెట్ స్కీమా
SQL schema something
SQL language or SQL script.
అది యూజ్ చేసినప్పుడు ఈ స్టేట్మెంట్స్ యూజ్ చేయొచ్చా?
Yes. He's asking me when you're implementing a procedure with complete syntax, as part of full syntax you specify saying SQL language is SQL script, right? So even C
Yes,
function is also considered SQL script only. Yeah, this is nothing. This is also a script, SQL script itself. Yeah, but the only thing is when you're using these functions, do not go with normal SQL. If you mix up both, system has to keep shifting from one engine to engine. The performance is bad. Yeah.
Okay.
Yeah. Now, first one. Do we have this table STS customer or I have STS customer 1. Okay, boss. I have this table STS dim customer 1. It's got something around 8 columns. So I just would want to read those 8 columns from this table, and that's my logic of the procedure. There's nothing. Just read all the columns from this table and then the print the same. Yeah. So what I'm doing here, demo sounds, that's my procedure name as begin and end. Look at the syntax here. I'm using it. C underscore column underscore table and the name of the table, nothing else. Within parenthesis, I pass in this. So C underscore column underscore table is this function which I'm using it to read from a column store table. So this is a column store, yeah. And then once the data comes into this temporary table, then I'm saying select star from this item. I'm just printing the results from that item. Yeah, that is it. So can I say, can this be equally written as itab equal to select star from, yeah? We can also write this and this, yeah. So for this SQL statement of select star from table, SAP has given this E column table function. Okay. I'm just calling that procedure now. it does only printing of the table, nothing. It's just reading all the table data and then giving it to you. This way I can use a C column table function. Now can we use to read from table, but only I just want to read only certain columns of the table. Yeah. If that is the case, look at the syntax. I just want you to understand the syntax so that you see. Look at the syntax here. C underscore column underscore table, and then you specify the table name. Then after table name, you can say comma, then list out the attributes, nothing but the column names. And specifying these column names, since it is in the square brackets, it is optional. See, in the less than or greater than bracket, you replace the table name, and when it is in square brackets, that is optional. Bus here you have to list out attributes. Yeah. So understanding that syntax, what I say, I want to read from only certain columns. Look at this. This is how I go with. I tab C underscore column underscore table. This is a table name where I'm reading from, comma, and then within the square brackets you list out all the columns what you want to read. So by using the C underscore column underscore table, when you want to read only certain columns, we use this option. C underscore column underscore table, the table name, comma, then we list out all the columns within the square bracket, separate with commas there. That is it. This is how you can you can use this C underscore column underscore table for reading all the records from the table, all the columns or certain columns from the table. I'm just calling this, it prints only those 3 columns. Yeah. Okay.
Sir, so I have a question basically. So C functions, right? So how do you say they are optimized? Are they hitting some specific schema so they are optimized?
They're
They are better than C?
they're hitting calculation engine, which is stronger one than when compared to SQL engine. So that is optimized. Yeah.
Okay. Sir, I have a question.
Yeah. Yeah.
See, if you are using C functions, we are literally selecting the data twice, right? See, once while using the C function and other while using the select statement. So if you use a simple select statement, it's only one time we are reading the data.
You also
So,
have only one time, right? C underscore.
but again, when we are selecting the data from the internal table,
So
will that,
no. See, it is not mandatory for me to read this. Yeah, for me to show you the result. This is not important for me.
okay.
Just to show you what is collected into the table, I'm just printing that. Yeah.
Sir, is this C table is valid for all the tables, all type of tables?
Only for column store tables.
Uh,
Okay.
yes, sir.
It does not support row store, only column store. Yeah. We can read from row store, but the C underscore column underscore table function is only to read from column store table only. Yeah.
Okay, sir. Thank you.
Say for example, to prove that, let's say I take this table out. So I have this look at the symbol, I know this is a row store table, right? I'm just placing the T here and say something like 1. See what does it say? What it says? Parameter must be valid. What is valid? What does it say?
Column table.
Column table. So C underscore column underscore table function can only be used when you want to read data from a column store table only. Yeah. The next one, we have something called C underscore join underscore view, right? So when do we use this bus? For you to make clearly understand what I'll do, let me just create simple attribute view. I'm not teaching you, but I just want to create one. Z80 Z9 80 something. We'll come to this topic later, but for now, I just wanted one. Say some table. See now, I'm activating this view. What is view name? Z980. This was an attribute view. What I created in this package, which one? 9 cube express. When I do this, it automatically creates a column view in sysbig schema. If you go to column views in sysbig schema, if I try to filter on mine, what was it? Z980, and see, I would see a column view. Look at this, 9 cubics slash Z980. So whenever you create an attribute view, it automatically creates a runtime column view, runtime object, which is a column view in sysbig schema here. So now I can just say straight away, I can say right click, open content. It shows me the data, right? So I can do a normal select, right? Look at this here. What is it? Select star from this. I can write that select, or I would like to use this C function and read this. So when you want to read data from a view, column view, which was deployed when attribute view was activated, then I'll have to use what? C underscore join underscore view. Instead of this, I'll try to put this and close this out. Now when I call this process, in turn you're reading the join results. So I think you understand this. Now C underscore join underscore view. Same way again, if you want to read, let's say it is giving me all the columns like this. Let's say you wanted to read only customer ID and customer type. Then you can list it out. You can say, and also choose the columns. I can say this is the column view I want, and these are the fields I would like to have from it. Say, then so like this, you can also use this C join view to read only some certain columns of the column view. Sorry. Customer underscore right. spelling, is it something different here? It has got special character, right? So put that in double quotes. Since it's got special characters, I've just put that in double quotes. Then it'll just call this procedure. Yeah. Like this, you can use a C join view to read only certain columns of the view also. Same way, when you want to read data from an analytical view, when you want to read data from the column view deployed from analytical view, now look at this. Look at the symbol, understand this. Now let me just create one analytical view, simple one. Don't worry about this, okay? We'll come to this topic later.
Sir, so the doubt is, so if you are hitting Z980, which is in Sysbig schema,
Yeah.
the it again hits the database, or the data is already stored or there ready-made
No. Column view is virtual, no?
virtual. So runtime objects are virtual and
Exactly.
data is not.
Yeah, exactly. So now I'm activating the Z9ANV. Activate. So I should see a runtime object in the Sysbig schema. Z9ANV. Yeah. Now look at this. You see this lot of column views, and the one with orange we call that as overlap catalog column view. So within this column views you'll have types like calculation column view, overlap catalog column view. This orange symbol indicates it's a overlap catalog column view. So when you want to read data from this overlap catalog column view, then I can use this C underscore overlap underscore view. So you can take this. Yes, so I'm just trying to read everything from the overlap view. So I'm saying C underscore overlap underscore view, and from this runtime overlap catalog views. Done. And then when I call this one, you just get all the content of this view. Okay, you can either do a select on this view or get this way. Similarly, you can also read certain columns also. Same way, next one is calculation view. Say other day we create this calculation view, right? You remember sales underscore reporting. So I would like to use it from the ready. So even that will have a runtime of sales underscore reporting. That was my 9 cubics. It will have the package hierarchy before that. So 9 cubics sales report. This is my view. So I'll say that's a calculation view column view, right? Look at this symbol. You see a calculator icon indicating calculation column view. So I want to read this calculation column view. I use this function C underscore calc underscore view. So by using the C underscore calc underscore view, I'm reading data from a column view which is deployed from the activation of calculation view boss. Yeah. Okay, I'm just activating this. And this. So this is in fact showing me the output of my column view. So like this, I can read data from a C underscore calc underscore view to read data from a calculation view. Yeah. So we'll stop it till today. Tomorrow we'll continue with other CE functions. Yeah.
Hello.
Yeah. Yeah.
Yes, sir, I have a question. See, if we have an attribute view built on a roster table, can we use this calculation
We cannot
function?
build attribute view on a row store table. Not possible.
Okay. And same is the case with analytical view and calculation view.
Analytical view straight away, no, you cannot. In calculation view, we cannot use row store directly, but there's a different way of doing it. What I can do is, in calculation view, we can build with by using scripting. Yeah, we'll have something called scripting based calculation views. What I'll do, I'll create one scripting based calculation saying select star from the row store table and use that calculation with others. I can do that way. But straight away flexibility of reading from a row store we do not have.
Okay. Okay.
Videos will receive it today. Yeah. And I'm sorry for other days I could not take classes. Still, you'll have that problem for another. Tomorrow I have a very important meeting in early morning, so I have to prepare something for that. Probably you'll still face this problem of not having classes tomorrow, day after tomorrow. Probably you'll have it. If not, I'll inform early. Yeah. But after Wednesday, I think the classes will be regular bus because I'm busy with something else. That's the reason. I'm really sorry for it. Yeah? If I'm troubling someone, I'm sorry. Yeah.
So, sir, another question. So you said that CE functions uses the CE engine, the OLAP engine or the join engine. So what is in there? I mean, does they calculate something differently using the engine?
Yeah.
What is the real advantage?
We'll see. We'll see when you're seeing about calculation views. But calculation engine instantiation is different from SQL engine instantiation. When I say instantiation, how does it create the runtime queries and run that results is different from difference in calculation engine and SQL engines. Yeah, we'll see that. Yeah.
Okay.
Yeah, we'll send those videos today. Yeah. Yeah. Please bear with me for another 2 days if I'm skipping classes. But please, yeah, sorry. If no class, we will inform you. No problem. Yeah. Please let us know by evening if there's no class. Sure. Yeah. I will let you know by evening if there's no class. Just bear me with 2 days, tomorrow and day after tomorrow. After that, I'll be in sync. Okay. Thank you. Any doubt else?
Hello.
Yeah, please.
Sir, in initial starting of the class, you told that for all entries is not applicable. We can't use in HANA. So, what is the replacement? As you said, we need to replace with for all entries with loop statement or like that. How it is?
See, I can show you. Normally, when you have for all entries, it says not a good option when you're working out with HANA as a backend database. Yeah. And in that case, you basically use the loop statement and access, or what you can do, you can collect the temporary table and access it. Yeah.
Okay, so as you said, we need to collect a result set in one table. So based on result table, we need to process the data. You mean, right?
Exactly. Collect the two tables data into temporary tables, then join them. Yeah.
Okay.
Yeah. Fine. Boss. Thank you. Yeah. Any other question? You want me to wait? Okay, boss. Fine. Thank you.